In example 26, we're asked to think about a nuclear chain reaction where energy is released from nuclei, and we're given some statements to describe the beginning of a chain reaction. Now, if you just want to check in your notes on page 27, you have a description there of a chain reaction. And what happens is we begin with uranium-235, which is actually stable and won't really do anything by itself. So in order to make it do anything, we need to make it unstable. And we do that by getting it to absorb a neutron in here. And this is what we call induced fission. So once it's absorbed a neutron, it becomes uranium-236, which is unstable, and eventually that breaks apart to give these two daughter nuclei, barium and krypton, plus 3 additional neutrons. And this is the idea of a chain reaction, which is that these 3 neutrons from the one that you started with could then go on to trigger 3 more uranium disintegrations. So if we look again at the question, which describes the beginning of the chain reaction, what happens in the beginning is a neutron is absorbed by a uranium nucleus, causing it to break apart. So it's this one, a neutron splits a nucleus, releasing more neutrons. It's option E. So a neutron splits a nucleus, releasing more neutrons. Example 27 is very similar. In a nuclear reactor, uranium nuclei are bombarded with neutrons, and they may absorb a neutron and then break up, releasing further neutrons and energy. So the nucleus contains 2 types of particle, name these. So by now you should be quite happy with the idea that the nucleus comprises a collection of protons and neutrons. Part B, what is the name given to the process shown in the diagram? So this is fission, but it's induced nuclear fission. So this is induced because it's absorbing, it's happening because a neutron is absorbed. The other kind of fission is spontaneous fission, which is where something is unstable by itself and eventually will just break apart. Part C, explain why the fuel rods have to be replaced after a certain time. So the fuel rods contain a very large number, so it's a very large but fixed number of uranium nuclei. Eventually, many of these nuclei will have broken apart. So they will have undergone fission and they will no longer be available to take part. In the chain reaction.